Good evening, Mahaganadhipataye. Good evening, children. Good evening to all. Good evening. Yeah, Mahaganadhipataye. Morning, we are discussing circles in the class. So I told you to draw a circle and a line on a flat surface. In how many different ways that we can draw? This was the question from my side. And we got three different ways. What is that? A circle doesn't, a line, they will not intersect each other. They will not intersect each other. This is one condition. Second condition, the line and circle both intersect at one point. At one point. Third condition, the circle and the line, they intersect at 2 points. These are the three conditions, or these are the three ways that we can draw, three different ways that we can draw on a flat surface. Three different ways. Here, no common point means the circle and the line both are not intersecting. That means they don't have any common point. Here, the circle and the line both are having only one common point, one point in common. They have only one point in common. And here, third case, the circle and the line both are having 2 points in common. I asked a question that can we draw a circle and a line such that both are having 3 points in common? And what is your answer in the morning? What is your answer, children? No. We cannot draw a line as well as a circle which are having 3 points in common. Okay. Now, I am going to rub these two cases. I am going to rub these two cases. Okay. And we are left with only this case. A circle and a line both are intersecting at one point. They are intersecting one point, at one point. Or you can say that a line and the circle both are having 1 point in common. Okay? If it happens so, then we can say that line L is a tangent to the circle with the center O at P. What we can say? Line L is tangent at P. It is tangent at P. To whom? To the circle with center O. Okay, na? P is the only common point. P is the only common point. Okay? Means line L intersecting the circle at one and only one point. That is P. Okay, na? That's why line L is called tangent to the circle at P. Tangent to the circle at P. ఇక్కడ P అనేది very very important. అందుకని నేను అన్నిసార్లు చెప్తున్నా. P is very much important. You cannot say line L is tangent. You need to specify the common point also every time. Line L is tangent at P to the circle with center O. Okay, na? Now you can see here. There is another circle and there is another tangent. Observe this figure. Line M is tangent to the circle with center P at R. That is what you have to understand. Line M is a tangent to the circle with center P at R. That common point you have to specify every time. Okay, right? Now, a circle is having how many points on it? A circle is having how many points on it? Can anyone say? Infinite. Yes. A circle is having infinite number of points on it. Very good. Now, take it granted that at every point on the circle, we can draw a tangent. At every point on the circle, we can draw a tangent. What is the meaning of it? Okay. A circle is having infinite number of points on it. At every point, we can draw a tangent. At every point, we can draw a tangent. Okay. That means to a circle, how many tangents that we can draw? To a circle, how many tangents that we can draw? Once again, I am repeating. A circle is having infinite number of points on it. Is that right? A circle is nothing but collection of infinite number of points which are at a fixed distance from a fixed point. Is that right? So, since it consists of infinite number of points, at each and every point on the circle, at each and every point, we can draw a tangent. We can draw a tangent. At each and every point, we can draw a tangent. Okay? Now, since a circle is having infinite number of points on it, so at every point we can draw a tangent. That means to a circle we can draw infinite number of tangents. To a circle we can draw infinite number of tangents. This is one more important point that you have to understand. Okay. Second point, which is also very important. At one point we can draw only one tangent. At one point we can draw only one tangent. Understand? What is the meaning of it? There is a circle with center O. There is a line L, tangent at P. Line L is tangent at P. Now, can we draw another tangent at P other than L? No. That is what he says. At one point, we can draw only one tangent. At one point, we can draw only one tangent. Okay, children? Once again, I am repeating both the points. A circle is having infinite number of points on it. At every point, we can draw a tangent. At every point, we can draw a tangent. This figure shows that. Now, second point is, at one point, we can draw only one tangent. Okay, na? At one point, we can draw only one tangent. These 2 points you have to keep in mind. Now, children, can anyone say real life examples for tangents to a circle? Real life examples for a tangent to a circle. Anyone? Wheels. Lohitaksh, correct. So you are riding a cycle, bicycle, or you are in a car, whatever it may be. Imagine your car tires or cycle tires or circles, and the road is tangent to them. Road is tangent to them. Did you understand? Okay, na? Sign of male gender. అలాగే పాతకాలంలో ఓల్డెన్ డేస్ లో బావి ఉండేవి, పుల్లీస్ ఉండేవి. దాంట్లో థ్రెడ్ అండ్ పుల్లీ అండ్ థ్రెడ్. థ్రెడ్ ఈజ్ అ టాంజెంట్ అండ్ పుల్లీ ఈజ్ అ సర్కిల్. Did you understand, children? So we can see real life examples like that. Now, I am going to explain a theorem 1, that which is very important. Before explaining that theorem, I want to tell you one thing. Once again, I want to clear the definition of tangent to you, which is very much necessary to prove the theorem. Yeah. Here, L is tangent to the circle with center O at P. Now, think about P. Children, think about P. What can you say about P? What can you say about P? What we can say about P? No answers. It is the common point for both the circle and the line. Okay. It is a point where tangents meet. point of contact of tangent with circle. An intersection of circle and the line. Okay. ఇంకా కొంచెం లోతుగా ఆలోచించాలి. Okay, it is called as point of contact. It is the common point for both the circle and as well as the line. All these are correct only, but you need to go little bit intersection of line. Intersection of line means point that is common point where the tangent form. Koncham deep here, I need to go little bit deeper. Yeah, okay. P is the only point which is common to the circle as well as the line. That is also right. Okay. P is called as point of contact. That is also right. Okay. P is called as point of contact. That is also right. Yeah. I will tell you one statement, children. If it is true, you can say yes, sir. If it is false, you can say no, sir. Okay? Except P, remaining all points on the line lies outside the circle. Except P, remaining all points on the line L lies outside the circle. Yes. Good. A line is having infinite number of points on it, and even circle is also having infinite number of points on it. But P is the only point which lies on the circle and on the line. It lies on the circle as well as on the line. Except P, all the points on the line lies outside the circle. If it happens so, then we can say that L is tangent to the circle at P. L is tangent to the circle with center O at P. Okay, na? Did you understand, children? Keep this point in the mind. Keep this point in the mind, because it is necessary to prove. It is necessary to prove the theorem what we are going to deal now. Now the theorem is we need to prove radius is perpendicular to the tangent at their point of contact. That is, prove that radius is perpendicular to the tangent at P. That is what we have to prove. Theorem number 1. Radius is perpendicular to the tangent at their point of contact. That is the theorem. So what is given? Line L is a tangent at Line L is a tangent to the circle with center O at P. This is given. Okay. Now what is required to prove? Radius is perpendicular to tangent at P. That is I am considering some points on the line L. Okay. I need to prove angle OPC or OPD or OP, whatever it may be, I need to prove it is 90 degrees. Okay, na? And let it be angle OPC. OPC is 90. Either OPC or OPD or OPE or OPB, OPA, whatever it may be, it is 90 degrees. I have to prove. Okay. Now, proof. Construction. What I do? I join all the points. From the center to the other points on the line. Okay? Now you tell me OA, OP. What relation exists between these two? OA, OP. What relation exists between these two? Yes, OA less than OB. Lohitaksh. A is a point on the line other than P. I think A lies outside the circle according to the statement I told. What no? Everyone says OA greater than OP. What about you, Lohitaksh? OA greater than OP. Then what about OB? I think it is also greater than OP. OC greater than OP. OD greater than OP. OE greater than OP. Is that right? So whatever the point you take and join with the center, so length of that line segment is always greater than OP. Is that right? It is always greater than OP. That means, can I say OP is the shortest distance from center O to the line L? Can I say OP is the shortest distance from center to the line L? Yeah. Good. Now, so that means OP is the shortest distance from the center to the line L, and we know that shortest distance is nothing but perpendicular distance. Is that right? Shortest distance is nothing but perpendicular distance. Is that right, children? Yeah. That means OP is perpendicular to L. OP is perpendicular to L. But what is OP? What is OP? Radius. OP is radius. So radius is perpendicular to the tangent L at P. Radius is perpendicular to the tangent at P. Okay, na? So this is the theorem 1. Okay, children. So angle OPC or OPD or OPE, whatever it may be, is 90 degrees. So this theorem is very, very important in problem solving. Okay, na, children? Next, yeah, there is a circle with center O and there is a point P which lies outside the circle. Now you tell me, children, from this point P, how many lines that we can draw to the circle? Anyone? From P to the circle O, to the circle with center O, how many lines that we can draw? From P, radius. What radius? Only one. So from P we can draw only one line. Did I say like that? Listen to me carefully. From P to the circle we can draw how many lines? Shyam says infinite lines. How it is possible? How many we can draw? From P to the circle with center O, we can draw infinite number of lines. Out of these infinite number of lines, we can observe only two are tangents. Okay, na? Out of these infinite number of lines, we can clearly observe that out of these infinite number of lines, only two lines, we can say that they are tangents from P to the circle with center O, only two tangents. So that means there is a statement called from a point which lies outside the circle, we can draw only two tangents to the circle. Okay, na? From a point which lies outside the circle, we can draw only two tangents. Did Did you understand, children? Is that understood? Yeah. And tomorrow in the class we are going to prove that the two tangents that can be drawn from P to circle with center O, they have equal in length. They have equal in length. See here, PA is one tangent, PB is another tangent. Tomorrow we are going to prove PA is equal to PB. Length of PA is equal to length of PB. So the next theorem is length of tangents drawn from an external point of a circle are equal. Or tangents drawn from an external point to a circle are equal in length. That is what we are going to prove tomorrow. So today what I will do, I will keep a video in the group. So kindly everyone go through that video now only after this class and come back tomorrow to the school. I will ask some questions from that video. Everyone. Okay na? After this class, I will share that video. Everyone has to see that video. Okay? And we will discuss about that video tomorrow in the class. Okay, children? Okay, bye. Thank you very much. Click on the like button. See, is it necessary to say everyone every day, right? When you enter into the class, immediately click on the like button. Tejal, take the attendance. Today also 31 only. Arey, 31 likes I want. Highest likes in my life. Everyone. Click on the like button. Please. 31 likes I want. ఒక్కసారి చేయండి రా, చెప్పిన మాట వినండిరా. ఇంకా 20నే. Only 22. 31 I want. Oh.